Okay, so let's look at this integration again. Before we go through these subtopics, let's do a very quick revision on all the integration formula that we know so far. So if you have integrations of a, it becomes ax plus c. If you have integration of ax to the power of n, it becomes ax to the power of n plus 1 over n plus 1 plus c. So if you have integration of ax plus b to the power of n, so it becomes ax plus b to the power of n plus 1 over n plus 1 a plus c. So at least we need to know these three formula in order to handle the questions. And at the meantime, you also need to know, before you integrate, that means this one, they are all known as dy dx. Before you integrate, they are dy dx. So which is gradient function. After you integrate, that means this one. So after you integrate, so we call this y, which is equation of a curve. Okay. Before you integrate, we call it gradient function. Gradient function means a formula to find the gradient. Okay, equation of curve, of course you should know, it's the equation that represents the curve. Okay, now if you have this as your basic concept, then it will be easier to understand the part D here. So now let's take a look. Okay, part D. As you can see, the topic here. Okay, so our topic here, what they say is, find the equation of the curve given its gradient function. So that means they give you the dy dx. You see, gradient function is dy dx. So they give you gradient function. What you need to do is you have to integrate the gradient function. Like what I put here, you integrate all these blue circles. They are gradient functions. Then you will get your answer. Your answer is equation of a curve. Okay, so we need to integrate the dy dx basically. Then they give you a point. They give you a point that passes through the curve. The reason why they give you this point is for us to find c. You know, when you do integration, c is coming out. And you want to know the value of c, you just need to substitute the x and y with the values given as a point here. So let's say example. Okay, so we can just write like this. Let's say for this question, gradient function dy dx equal to 2x minus 5. So you just need to integrate the gradient function, and you can put y in front, because after you integrate you will get equation of curve. Equation of curve is y. So y equal to integrate 2x minus 5. Then when you want to integrate 2x, so you just stick to the second formula here, which is this formula, 2x to the power of 1. So it becomes 2x to the power of 2 divided by 2. Okay, so it becomes 2x to the power of 2 divided by 2. Minus with, okay, so now we have 5. So imagine 5, you look at the first formula, 5, it becomes 5x. Okay, 5x. So the 5 integrate, it becomes 5x. 5x. Plus c, we write one time only. Okay, so we just put plus c at the end. Okay, now after integration, we get this. This is equation of the curve. but we need to find the c also. So we substitute minus 1, 4. So y is equal to 4. The 2 I cut away. So x replace with minus 1 in this way plus c. So 4 equal to 1 plus 5 plus c. C equal to 4 minus 6, which is negative 2. And then we get y equal to x squared minus 5x minus 2. Okay, so we get the equation of curve. So from here you will see the general idea of doing this is integrate the dy dx. Okay, so integrate the dy dx. Integrate dy dx, then you will get y. Okay, so after you integrate dy dx, second step, find c. Find c, and at the end what you get is equation of the curve. Okay, so this is part D. Okay, now let's move on. Okay, so remember sometimes we have to use the third formula also. For example, like this one, number 5. If you meet something like this, 2x minus 8 to the power of 3, then you have to use the third formula. So the third formula to integrate will be like this, and at the end you will get the equation of curve also. You just need to use this formula to handle it. Okay, so let's move on. Okay, now we have 3.3, definite integral. So for definite integral, you will see something like this. You will see numbers. You will see numbers on top here and at the bottom of the integral sign. So of course the number on top is known as upper limit, and then the number at the bottom is lower limit. Okay, so let us go through the formula first to understand a little bit. Okay, so you see just now I said the formula of integration. If you have integrations of a, then it becomes ax plus c. Ax plus c. So if you have the integrations of a with upper lower limit, so let's say the upper limit is p, the lower limit is q, and now there are upper limits and lower limits here. So what happened is it is still ax, but we don't want plus c anymore. It's still ax. The integration method is still the same. We don't want plus c anymore. We put a square bracket, then we put p and q, the upper limit and the lower limit. Then after that, we use the upper limit first. We substitute the upper limit into the x, and we get ap minus with aq. So we get something like this. Okay, so this is the first situation. You will see no more c over there. No more c. So you see just now I also mentioned the second formula is ax to the power of n. And when you integrate, it becomes ax to the power of n plus 1 over n plus 1 plus c. So it becomes this. But if you have limits now, let's say if you have limit p and q, ax to the power of n, the way to integrate is the same, like ax to the power of n plus 1 over n plus 1. The only difference is we don't want plus c anymore. We just put a square bracket straight away, and then we put the upper limit followed by the lower limit, and we use the upper limit first by substituting the p into x. Then we get ap to the power of n plus 1 over n plus 1 minus, now we use the lower limit. We substitute the lower limit into the x. So aq to the power of n plus 1 over n plus 1. So this is the second situation. Okay, now I give you one more situation. Just now the third formula that I mentioned is integration of ax plus b to the power of n. And when you integrate this, you will get ax plus b to the power of n plus 1 over a over n plus 1 plus c. So if there is no limits given, so we use the formula in this way with plus c at the back. Now if we have limit p and q, ax plus b to the power of n, so the way to do it, we integrate it like usual, like the formula, and again we don't want plus c. Then we put a square bracket like this, we put upper limit followed by lower limit, and after that you substitute p into x. This one look like x, this one I cancel a bit, I make it looks more like a bracket, if not later you misunderstand. This is a bracket and not x, so the x is staying on top. Okay, so ap plus b to the power of n plus 1 over a n plus 1 minus, and now we substitute q into x, so aq plus b to the power of n plus 1 over a over n plus 1. So we substitute like that. Okay, then you will see in general the situation will be like this. They just put everything in general only. Okay, now you see the tips here, this one. So if you have integration of fx equal to gx plus c, I have to say plus c. Okay, if you integrate fx, you get gx plus c, let's say. Now when you have limits given, integration from lower limit a to upper limit b, when you integrate fx, okay, you will still get gx, you don't want plus c, you put square bracket, then upper limit and the lower limit. And now you have to, they put everything in general actually. And now you have to substitute the upper limit into x, then you get gb. Then you minus, always minus one, always minus. You see our formula, always minus. Okay, the formula that I put just now, all these minus one, as in here, minus, this one, minus, and the last situation also, minus, so as you can see here, minus. That means you substitute upper limit inside, and minus with the substitution of the lower limit. Okay, so always minus. So that's why over here you can see, after you substitute upper limit to the functions, to the results of integration, then always minus, followed by the substitution of lower limit. Okay, so let's see example. Okay, now we integrate this one. Maybe you are wondering, for this example A, okay, should I integrate it by using this formula followed by this formula? That means integrate 4x by using this formula, then integrate 4 by using this formula, integrate one by one, in other words. Or should I integrate it by using the third formula, where I take this as, you see nothing outside of the bracket, so I take that as power 1. So which one is correct? Actually both are correct. Okay, both are correct. So you can integrate one by one, or you can integrate everything straight away by using the third formula. Both will be correct. Okay, but if there is a power outside, let's say this is power 2, outside of the bracket you have power 2, then you cannot integrate one by one anymore, you must use this. But if there is no power, then you can integrate one by one, or you can take it as power 1 and integrate in this way. So both will be just fine. So of course, if I'm doing which way am I going to use? I will just integrate one by one. I know this is 4x to the power of 1, so integrate this, we'll get 4x to the power of 2 over 2. Integrate 4, become 4x. And then I put a square bracket, followed by upper limit, followed by lower limit. Okay, let's say I put two methods here. So this is alternative. Let's see, same answer. So like what I said, you can also use the third formula. You assume ax plus b to the power of 1, you know. So for this case, 4x minus 4 to the power of 1. Based on the formula, it becomes 4x minus 4 to the power of 2 divided by 2 divided by 4. Upper limit 3, lower limit 1. Okay, so I will do both at the same time. So you can integrate one by one, then you can refer to the method on the left. Integrate one by one. Or you can integrate the whole thing as power 1, so it becomes power 2 over the a. The a is this 4. So both will be fine. Okay, now we continue. We substitute the upper limit into x. Okay, so there are two places to substitute. Okay, so this is 2x squared at the end. So it becomes 2, 3 squared minus 4, 3. Substitute 1 inside. 2, 1 squared minus 4, 1. And then we check with calculator. So the idea is you substitute upper limit into whatever result you get, then minus with the substitution of the lower limit to the result. Okay, now I press calculator. 2 times 9 minus 4 times 3. So the front part I get 6. The second bracket, 2 minus 4, I get negative 2. So at the end I get 8. Okay, let's see alternative method. Same idea. I substitute 3 to the x. So 4 times 3, 12. 12 minus 4, 8. 8 power 2, 64. 64 divided by the bottom, 8. 64 divided by 8. Okay, 8 only lah. Okay, so now minus with the substitution of the lower limit, substitute 1 inside. Substitute 1 into the x. So I just count straight away, no space. So I substitute 1 on top. 4 minus 4 becomes 0, 0 divided by whatever is still 0. At the end, 8. So same answer. Okay, so no matter you use which way, then at the end, same answer. Okay, now let's see one more example. For this case, if you have something with power 3, then you have to use the third formula. The third formula, which is this one. Okay, which is this one, the third formula. You cannot use the first and second anymore. You cannot integrate one by one anymore. You must integrate everything as a whole with power of something. Okay, and we cannot leave the bracket with power at the bottom. We must bring it up before you use the formula. So that means we have to do something like this. For 10, we just leave it. No need to do anything. I can even put it outside. If you want to put inside, it's okay. If you want to factorize it and put outside, it is okay also. Okay, and no need to integrate it. Don't change 10 to 10x, you know. So no need to do it in that way. So if in what situation you need to change 10 to 10x, and in what situation no need. For example, if your question is 10 plus x plus 3 minus 3, and then yes, you have to change 10 to 10x. But for this situation is 10 x plus 3 minus 3. This situation, the tan you just remain it. Don't change it to tan x. Just remain it. Remain it or factorize it is up to you. I like to factorize. Okay, so just leave it outside. Don't change to tan x. Just leave it like that. So make sure you see the difference. The difference is, for this one, we change to tan x. For our example down here, we remain it as 10. Okay, so what is the difference between this and this? It is quite obvious. This is a term, a separated term. When there is a plus minus in between, then this is counted as a term. If it is a term, then you have to integrate it. Okay, so if they are multiplying, then this is not a term. So this is together with this one. They are together as one term. So then if they are multiplying or dividing, no need to integrate. The constant, just leave it there. So if they are plus minus, then you need to integrate it. So make sure you see the difference. Okay, so plus minus, you have to integrate the 10. Multiplying or dividing, no need to integrate the 10. Just leave it there. Okay, so I continue. The 10, just leave it there. And then for the rest, you have to look at the formula, the third formula. Okay, so which is this one. So this one. So we are using this formula. The power have to increase by 1 unit. So which means we are going to have x plus 3 to the power of negative 2. Divide by two numbers. So the first one is the a, the coefficients of x. The second one is the n plus 1, the new power. So the coefficients of x is 1. You see in front of x there is no number, so which means a is 1. So you have to divide by 1. You have to divide by the n plus 1, which is minus 2. Okay, so we need to divide by 1, divide by minus 2. And then we put a upper lower limit like this. Okay, now we continue here. Equal to okay, substitute now. Or if you don't want to substitute, you can simplify first. So you see how we simplify. First, 10 and minus 2 can simplify into negative 5. You can just divide that like usual. 10 divided by negative 2, you get negative 5. Negative 5 you can put outside or you can put inside, it's up to you. Okay, let's say I put outside. Okay, now for the bracket, because it's negative power, so I can bring it down. I bring it down, it takes positive power. 0 minus 2. Okay, now we substitute. Substitute 0. 0 plus 3 is 3. 3 power 2. 1 over 9. Substitute negative 2 inside. I get 1. Minus 1. Okay, then 1 over 9 minus 1. Multiply with negative 5. 40 over 9. 40 over 9. So that is the answer. Okay. Now let's talk about the meaning of your answer. Okay, the meaning of your answer. So you see, I put two situations. I put two simple situations. Then I try to explain to you. Just now, before these two examples, we learn integration without limit. So let's say I give you the simple one. Okay, let's say I integrate 4x minus 4 again. 4x minus 4. I purposely choose 4x minus 4 because it's same with the example here. So same with the example here. So if there is no limit, I integrate 4x minus 4. Then I will get 4x squared over 2 minus 4x plus c then I will get 2x squared minus 4x plus c. And then they will give you a point, and you can find the c. Okay, and what you get is equation of curve. So you get equation of curve. So you find c. Use coordinate given to find c. Then you will get y equal to something. That is equation of curve. So you will get an equation of curve. Okay, so at the end you can draw the curve. You can draw the curve. Basically the curve is a quadratic curve, something like that. Okay, you will draw a curve. You are able to get the equation of curve. So which means what we learned before is they give you dy dx, you integrate, and then you get equation of curve. But now let's say I use this as my example. Okay, now you have number, lower limit, upper limit. You are integrating the same thing. You get 8. What is meant by 8? Okay, let me explain it in this way. When you integrate, okay, I put a little bit of space in front. When you integrate 3, 1, 4x minus 4, now we have limit dx. You integrate, you get 8. 8 is what? Is it equation of curve? Of course no. Okay, it's not equation of curve. Just now, when there is no limit, you get equation of curve. Now you have limit, you don't get equation of curve. So then what is 8 mean? What is the meaning of 8 over here? Okay, so it is something like this. 4x minus 4. Just now we call it dy dx. Okay, now you can call it dy dx. You can call it dy dx, which is gradient function if you want. You can still call it gradient function if you want, but I rather call it a graph. You can call it gradient function or graph, it's up to you, but calling it graph will be more suitable. So 4x minus 4 is a graph. 8 is area under the graph. From x equal to 1 to x equal to 3. Okay, so let's say example. How does it look like? Okay, so I draw it out and you see how does it look like. The graph is 4x minus 4. It's basically a straight line. Okay, the straight line 4x minus 4 is a graph that is very easy to draw, just like that only, where this is the y-intercept minus 4. The x-intercept, you can imagine, you can imagine something like this. Y equal to 4x minus 4, the x-intercept, you let y equal to 0, 4x minus 4, x equal to 1, so the x-intercept is 1. Okay, now I say the answer that we get, 8, is area under the graph from x equal to 1 to x equal to 3. So x equal to 3 is somewhere here. So you can see x equal to 1 is here, x equal to 3 is here, area under the graph is here, this area. So this area is 8 unit square. So you can get it from the integration with lower and upper limit. So it has different application. So without limit, you are finding equation of curve. with limit, you are finding area under the graph. So different situation. Okay, now let's move on. Okay. Next page. Part B. Given integration of 1 to 4 equal to 6. Find each of the following. Okay, so let's see this one. Integration from 4 to 1, 7fx dx. Okay, now before you look at this example, so I think it's good to know some basic formula, some relevant formula. Okay, so the relevant formula will be like this. The relevant formula to handle this situation. Okay, so first, if you have let's say PQ, okay, let's say PQ, let's say AB, fx with a constant outside, with a constant that multiply with this, we can factorize the constant. Okay, so this is one of the formula that is helpful or that is relevant to our practice in part B. Okay, the second formula that is relevant will be this one. If they give you limit fb, you can turn the limit upside down, become the other way around. Okay, so if you turn it upside down, then you have to put a negative in front. So that is the second formula. Okay, the second formula. And the third formula that is relevant to part B is this one. If you have fx plus gx, two terms, that you need to integrate. So we can separate into two integration. You integrate fx plus you integrate gx. So these are the relevant formula. Okay, the relevant formula. You can separate and integrate. Okay, so one more formula that I need to go through here. So there is another situation that we need to know. This one I need to put in number line. Let's say A is here, B is here, C is here. A, B, C. A is the smallest number, B is a bit greater than A, and C is also greater than B. Okay, C is the greatest. Okay, so you have three numbers, and let's say they are x. Okay, now you try to imagine in this way. If you integrate A to C, fx dx. If you integrate A to C, fx dx. If you still remember what am I trying to explain just now, I said when you integrate fx is known as the graph. Then after that you do integration, you get a number, right? The number is area under the graph. So let's say fx is like that, the graph is like this. I just simply draw a graph. I let you imagine only. So if you integrate fx from A to C, right? So basically you are finding the area from A to C. So you're integrating, you're finding the whole blue color area. So the blue color area, so this is the this thing represents the blue region. Blue region. Okay, now you see our formula. We can break down to integration of a to b plus integration of b to c. I can break down. Okay, so how to understand it? By using our graph over there. So if you integrate from a to b fx dx, so it's basically the area under the green color region. Green region. You integrate that, you get that area, a to b. Okay, and let's say I use yellow now. So when you integrate b to c, you get yellow region. Yellow region is here to here. Yellow region. So because of that, you try to imagine, integrate a to b is here to here, you get area under the graph, the green region. Integrate b to c, fx dx is the area under the graph from b to c, the yellow region. So if you add up this and this, you add up the green region and the yellow region, of course you get the blue region. So this formula can be understood in that way by looking at area under the graph. Okay, so this one I call it formula number 4. Formula number 4. Okay, now let us apply it. I will tell you which formula am I applying when I do the example here. Okay, so I number it first. Formula 1, 2, 3, 4. Okay, now we see the example there. Our example, integrate 1, 4, 7 fx. Okay, so first I need to apply formula 2 to turn the limit upside down, then the negative will come up. Okay, so I'm using formula 2. Formula 2, Formula 2. 1, 4. I turn the limit. When I turn the limit in that way, a negative will come up. Negative come up. Why we need to turn it? Okay, maybe you're wondering why we want to turn it upside down, why we want to change the 1, 4 to 4, 1. The reason is because the information given is 4, 1. So we try to turn it upside down so that our questions same with the information given. Then later we can use the information, so we have to change it to the same form. Okay, change it to the same form. Okay, now what else to do? The 7. Use formula 1. Based on formula 1, constant can be taken out. 7 can be taken out. Then we get negative 7 now. Okay, this is based on formula 1. I take out 7. That's based on formula 1. So after doing all this, right, and then we can use the information given where integrate 4, 1 fx dx is equal to 6. It's equal to 6. This one is equal to 6. Why this is equal to 6? Because the question tells us this. Integrate fx dx from 4 to 1 is from 1 to 4 is 6. It's 6. It's given. So that's why this whole color thing in the blue box is 6. Okay, it's 6. So we get negative 7 times 6, negative 42. Negative 42. Okay, so that's the thing. Negative 42. Okay, so that is how we use the formula 2 and 1. Okay, maybe you feel like, oh, how about formula 3 and formula 4? Okay, let's take a look. I choose a question that use formula 3 and 4. Okay, I do question 3. Okay, question 3, yeah. Question 3 involve formula 3 and 4. Okay, so first of all, when you look at question 3, you have integration of fx plus 3. Fx plus 3. We can separate them based on formula 3. Okay, I use formula 3 first. Formula 3 can separate into integration of fx, integration of 3. So I separate already. That's based on formula 3. At the same time, I use formula 2 for the back one. I use formula 2. Okay. Based on formula 2, you see it again, huh? You can turn the limit upside down. Turn the limit upside down, then a negative will come out. So I want to turn the limit upside down, become 4 2 instead of 2 4, and then this one will change sign because there's another negative that come out, so we make this to be positive at the end, so it become positive 4 2 fx dx. Okay, so maybe you are also wondering, why you want to turn the limit upside down? What is the reason? Okay, so I want to use formula number 4. Okay, formula number 4. So you see how I use it. Before I use it, let's say I gather up, integrate 1 to 2 fx dx, integrate 2 to 4 fx dx. I gather up these two first. Integrate 1 to 2 3 dx. This one I put at the back. For all these, I can use formula 4. Formula 4. Based on formula 4, integrate a to b plus integrate b to c, at the end will become integrate a to c. Something like 1 to 2, 2 to 4. If you combine, then it's 1 to 4. It's 1 to 4. This one is like 1 to 2. This one is like 2 to 4. Combine, become 1 to 4. So that is formula 4, which is more complicated one. You have to like imagine, join up the region. Okay, so integrate 1 to 4 fx dx. So why we need to do like that? Because when you join them up to become 1 to 4, then you can use this information, which is equal to 6. That means this whole thing is 6. Then how about this? This is integration of 3 from 1 to 2. What should we do? The information don't give any information on this. If they don't give any information on that, you need to integrate it as usual by using the basic formula that we discussed just now. So that means you have to integrate 3 to 3x. 3x. So integration of 3 become 3x, followed by the upper limit and the lower limit. And that is what we learn also, So in the in today lessons. Okay, now the front part. Integrate fx dx is equal to 6. So all these, here until here, all these are 6. Okay, so all these is equal to 6. It's given by the question. Okay, now the back one. I hope you still remember how to handle the back one. We substitute the upper limit into x. Substitute the upper limit 3, 2 minus with the substitution of the lower limit. And then just count everything here. 6 plus 6, 12, 12 minus 3 is 9, equal to 9. So from here you see something, we need to use 4 of this formula in order to solve question like this. So okay, let's see part C. Part C, okay, part C is quite same. You have to use that 4 formula also. This time they give us 2 information. The first one is integrations from -1 to 2 gx dx equal to -4. The second information, integrate 2 to 5 gx dx equal to 9. Find each of the following. Okay, example, integrate -1 to 5, 2x minus gx. Okay, so which formula should I use first? Okay, let's take a quick look. We can consider formula 3 first. Formula 3, this one. Separate the 2x and the gx into 2 separated integration. Like this. Formula 3. Okay, formula 3. Integrate -1 to 5 2x dx minus integrate -1 to 5 gx dx. Separate. So after we separate, then we see what to do here. We have to use, for the second integration, we have to use formula number 4. Okay, let's take a quick look. Formula number 4. Formula number 4. If they give you integration from -1 to 5 gx dx, then you can break down to 2 regions. Which 2 regions? You see the question, from -1 to 2, imagine -1 to 2 one region, 2 to 5 second region. You can break it down to 2 regions. Which 2 regions? Look at the question to get the idea. So we're into this region and that region. Okay, so that is based on formula 4. Based on formula 4, you can break down to 2 regions. Okay, so that means you can break down to -1 to 2 gx dx, 2 to 5 gx dx. Break down to 2 regions. For the integration in front, this one, what should we do? Just integrate like usual. Integrate 2x is like 2x to the power of 1. So 2x to the power of 1, you integrate, it becomes 2x to the power of 2 over 2 5 1, and that is 5 negative 1, sorry. Integration as usual. Then cut the 2 away, let's say. Okay, then as usual, you need to use the upper limit first. Use the 5 first. Substitute 5 into the x, 5 square, minus with, substitute -1 inside, -1 square. Okay, so we do something like this, followed by the information. Okay, so the information given, We have to use it now. Integrate gx from -1 to 2. This whole thing is equal to -4. Integrate 2 to 5. This whole thing is equal to 9. And then equal to, use calculator. Okay, 5 square 25 minus 1 minus -4 plus 9 19. Okay, so 19 the final answer. Okay, so from here you see quite many examples already on how we use the 4 formula here. Okay, so quite many examples already, and now let's see what we have on the next page. Oh, this is area under the curve. So I hold this first. We have to practice this later.